All right, what's good, Logan? So we're taking a look at the factor theorem today, and the factor theorem states that if you have f of x, right, it will have a factor of x minus k if and only if f of x is equal to 0, right? So when you read that, you're like, what? Like, what does that even mean? So basic idea here, basic theory is that if you recall, this right here, f of k is equal to 0, looks vaguely familiar to the remainder theorem, which states that f of k is equal to the remainder, or r. All right, and that's our foundation. That's what we're going to start with. So if the remainder happens to be 0, then we know something is a factor. And this relates back to the definition of what it means to be a factor. We'll take a look at this through the lens of a couple of examples. So let's take a look at our first example. It's got, is x minus 2 a factor of x squared plus 2x minus 4? So we start off by saying, okay, so then k, right? So we know our k value is 2. So now we're just going to do synthetic division on this thing right here. Okay, remember the remainder theorem states that f of k is equal to 0, so all we got to do is find the remainder. F of k equals the remainder, sorry. So all we have to do is find the remainder. And then we take the coefficients of what we're dividing, 1, 2, right? So 1x squared, 2x, and then negative 4. We're going to drop down the 1, and then we're going to multiply, and then we're going to combine, and then we're going to multiply, and then we're going to combine. All right, so what this tells us is because the remainder, or because f of k does not equal 0, then we now know that x minus 2 is not equal to 0. All right, so I'm going to just kind of write that down, make sure we understand this. So our understanding is that f of 2 is equal to 4. Now this indicates it is x, right? So we can conclude that x minus 2 is not a factor because it wasn't equal to 0. The f of 2 does not equal to 0, is not a factor. Now that's just short, like the answer, but like let's delve in a little bit deeper. Like, why is this the answer? So what we did is we have this thing we're dividing by. So we have our divisor, which is x minus 2. Sorry, I don't know if it's dividend or divisor. I always mess that one up. And then we have our quotient. So I do remember that guy, and this is our quotient right here, and it's x plus 4 plus the remainder of 4 plus the remainder of 4. Now this is equal to our original polynomial, x squared plus 2x minus 4. So by definition of factors, because this number here, the 4, exists, we know that it's not a factor. Now, if that 4 wasn't there, if that 4 was a 0, then it would have been a factor. But because we have that 4 right there, right, that 4 right there, we know it's not a factor. But if that 4 was gone, then these would have been our two factors, which it's not. Now, the way that I rewrote this is it's going to be really important for us because it's going to give us our two factors. If it was a factor, it's going to give us our what we divided by factor, and then it's going to give us our quotient of our factor. If this guy was 0, which it is not, so we can just conclude it is not a factor. All right, let's try this one more time. Second example, is x plus 5 a factor of 3x to the fourth plus 15x cubed minus x squared plus 25? We start off by identifying our k value. So our k in this problem is negative 5, and then we'll set up our synthetic division. So we'll negative 5, and then we'll write down the rest of the polynomial. We have a 3 for the x to the power of 4, and then we have a 15 for the next one, and then a negative 1 for the x squared, right? So negative 1. But we notice we have no x value. So I'm going to put a 0 right in there, and then I'll put a 25 for our no variable term, our constant term. And then we just drop the 3. That'll give us negative 15, which gives us 0, which gives us 0, which gives us negative 1, which gives us 5, which gives us 5, and gives us negative 25. Combine that, we get 0. So immediately we can conclude, right? So because f of negative 5 is equal to 0, we can conclude that x plus 5 is a factor. Yay! But here's the beauty, or the elegance of this, is that we actually have two factors now. We know that the original polynomial, 3x to the fourth plus 15x to the power of 3 minus x squared, has one factor, and that one factor is from this guy here, x plus 5. But the elegance comes in knowing that we have a second factor. So the x plus 5 factor is one of them, and our second factor is from the coefficients of our synthetic division, which will end up being 3x to the power of 3 minus x plus 5. So now not only do we have the original factor that we were checking for, but now we have the secondary factor, or the quotient factor. All right, if this doesn't make sense, hit me up. I'll go ahead and add an extra video on what to do with it once you've kind of found out that it is a factor. Other than that, I'll see you guys in class. Peace.